A rocket initially at rest, so what do we have? We have VI is equal to 0 meters per second, accelerates at 17 meters per second squared. How much time, so we want to find time, will it take for the rocket to achieve a velocity of 323 meters per second? So we have a rocket here. Not even going to try and draw a rocket. It's initially at rest, and at a later time, after accelerating for 17 meters per second squared, and this will be time is what we want to find, it is moving at 323 meters per second. So we have a couple of equations to work with here. One, the first one, the big one here, the acceleration is delta v over t, where delta v equals v final minus v initial. Well, in this case, for the delta v, that's easy. The initial velocity is 0, so our delta v is just v final. Now let's look at the other equation here, delta v over t. We need to solve this for t. So we multiply both sides by t to get t out of the denominator. And we now have TA is equal to delta v. We're getting closer, but we're trying to solve for t. So we divide both sides by acceleration, and we get t is equal to delta v over a. So now we're ready to substitute. Time is delta v over a. We found delta v, that's 323 meters per second. Divide that by the acceleration, I think they gave it to us, yep, 17 meters per second squared. Meters cancel out, and you bring up this 1 over second squared in the denominator, and it makes it second squared in the numerator. So what we'll have here is second squared that we bring up from the denominator, and the numerator still has this 1 over seconds. So that cancels out, and we get seconds, which is good because we're looking for time. Carry out the division, and we get time is equal to 19 seconds. And put a box around it. Our answer is C.